You think chaos means unpredictable, random, beyond control, but there's a secret buried in the quantum realm that flips everything you know upside down. Scientists discovered that the very chaos making weather impossible to forecast beyond a few days, stock markets impossible to time, and molecules impossible to model, that same chaos, when you drop to the quantum level, becomes your most powerful prediction tool. 7 explosive ways this paradox is rewriting the future you'll live in, and they're already happening. 40 years later, experimental proof. The team led by physicist Jairo Velasco Jr. confined electrons and watched them trace high-density orbits reinforced by wave interference. Not chaos, predictable paths emerging from apparent randomness. The paper states electrons could travel predictably across devices carrying information from one end to another by slightly nudging these orbits. Information processing transforms when you can guide electrons through chaos instead of fighting it. They employed dual unitary circuits to replicate chaotic behavior and tensor network error mitigation to manage noise. Their findings suggest quantum computers can address complex problems with applications in weather prediction, fluid dynamics, and material science. Not someday. Today's quantum technology handling chaos that classical computers choke on. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from Nature Journal published November 27, 2024, reporting on quantum scar experiments at UC Santa Cruz, and from IBM Quantum's ArcSiv preprint published November 4, 2024, on many-body quantum chaos simulations using 91 qubits. These aren't generic sources, these are bleeding-edge quantum physics from the institutions building the actual hardware. Now back to the information. The system accurately predicted storm paths and intensity 3 days earlier than standard models. No AA used quantum-powered forecasts during the 2024 Florida hurricane season. Their post-season report shows evacuation orders based on quantum-enhanced forecasts resulted in 20% fewer injuries and 15% reduction in property loss compared to previous years. Real people not getting hurt because quantum chaos mathematics caught the storm signatures classical computers missed. The World Meteorological Organization in 2025 praises these advances, noting quantum acceleration promises instant hyperlocal weather updates, receiving accurate tornado warnings minutes before disaster strikes. Prediction. They reformulated the 4-dimensional variational data assimilation problem from quadratic unconstrained optimization into quadratic unconstrained binary optimization for quantum annealers. They tested on D-Wave advantage physical quantum annealer and fixed stars, amplify simulated quantum annealer. D-Wave's physical quantum annealer required less than 0.05 seconds for computation, much faster than conventional quasi-Newton approaches. Weather forecasts that took hours now take fractions of a second. Algorithm on weather-related problems. The Lorenz 63 chaotic model serves as standard benchmark developed by Edward Lorenz in 1963. This simple mathematical representation has 3 variables changing over time in unpredictable ways. They trained reservoir computing models on Lorenz 63 state variables to forecast future trajectories capturing chaotic behavior. OQC Lucy quantum processor tested these hybrid quantum classical reservoir computing systems. Results matched noiseless simulations with reduced noise levels and 10,000 shots per measurement. Short-term and long-term predictions of chaotic dynamics validated. Reservoir computing analyzes sequential data, particularly in context of sequential prediction and pattern recognition tasks. Its quantum counterpart, quantum reservoir computing, explores disordered dynamics within quantum framework. Weather forecasting. To financial market analysis, understanding and predicting complex chaotic behavior, crucial for decision-making and planning across a wide range of fields. The modular structure of hybrid quantum reservoir computing means it's customizable to meet requirements of currently existing hardware. Results from ArcSiv paper 2311-14-105 demonstrate algorithms' ability to provide short-term and long-term predictions of chaotic dynamics. Team tested HQRCs and proof-of-concept experiment on OQC Lucy. Obtained results match noiseless simulations for setup with reduced noise levels and 10,000 shots per measurement. This paves way for exploration of more complex implementations of HQRC and scaling architecture to tackle higher dimensional problems with OQC Toshiko's chip hosting substantially more qubits. Climate prediction details good, bad, and noisy aspects. Paper explains. Introduction of noise can help reduce dimensionality of dynamical system. Suitable variable transformation of deterministic 3-dimensional Lorentz system yields 2-dimensional stochastic system. This offers potential route to gauge impact of noise in quantum computer using near-term quantum hardware. By integrating modified Lorentz system of reduced dimensionality on quantum solver imperfections of hardware, might allow exploration of chaotic behavior of effectively stochastic system and reproduce Lorentz attractor. Authors hope to shed light on potential applicability of future quantum computing technologies in weather and climate predictions. By making use of exponentially large state-space quantum computers, offer a range of advantages when it comes to processing large sets of data. These aren't marginal improvements. These are hundreds of people not injured, millions of dollars in property saved. Because quantum chaos mathematics caught storm signatures embedded in atmospheric data that classical computers process too slowly to extract meaningful patterns before the storm hits. Signs for extreme events. D-Wave's quantum cloud service processing petabytes of information at speeds that seem almost supernatural. Late 2024, completing 10-day European weather simulation in under 30 seconds. Task that would tie up fastest supercomputers for hours. This jaw-dropping speed means forecasters can update predictions in near real time as storms develop. World Meteorological Organization in 2025 praised these advances, noting quantum acceleration promises. New era of instant hyperlocal weather updates. This could mean receiving accurate tornado warning on your phone minutes before disaster strikes instead of generic countywide alerts that come too late. The quantum advantage isn't coming. It's measuring storm velocity and predicting tornado touchdowns right now. Drug discovery slashing a decade to months. January 22, 2025. Nature Biotechnology publishes Quantum Computing Enhanced Algorithm Unveiling Potential KRAS Inhibitors. KRAS protein, known for intricate complexity and historical resistance to drug discovery efforts. The team proposed hybrid quantum classical model combining quantum and classical approaches to generate compounds targeting KRAS for cancer therapy. They designed, selected, and synthesized 15 proposed molecules that notably engage with KRAS. 2 hold promise for future development as inhibitors. Quantum computing generated experimentally validated hits, comparing favorably against classical models. They used Virtual Flow 2.0 to screen 100 million molecules from Enamine Real Library containing vast chemical space of purchasable compounds, selecting top 250,000 with best docking scores based on computational predictions of how well molecules bind to KRAS protein target. They used stoned algorithm, superfast traversal optimization, novelty, exploration, and discovery on selfies, self-referencing, embedded strings. Molecular representation of known inhibitors generating structurally similar compounds that might have improved properties. Second stage involved hybrid quantum classical generative model for small molecule design, specifically targeting KRAS inhibitors for cancer therapy. Third stage experimental validation, where team actually synthesized 15 proposed molecules in laboratory testing, how they engage with KRAS protein. 2 molecules holding development promise, showing binding affinity and characteristics, suggesting they could work as cancer drugs with further optimization. This isn't theory. This is molecules synthesized in labs binding to cancer proteins that resisted drug discovery efforts for decades. Therapeutic from concept to market. 88% of drugs reaching clinical trials fail to gain approval. That failure rate represents massive waste of resources and time. More importantly, represents patients waiting for treatments that never arrive. Quantum computing changes the economics and timeline fundamentally. World Economic Forum published January 2024, titled AI and Quantum Revolution Will Transform Drug Development. Breaking through challenges posed by previously undruggable targets requires technology moving beyond AI into a world of first principles physics. When we don't have data for AI to design effective therapeutics, simulation can fill void, creating new datasets by digitally modeling biopharma compounds and rapidly simulating their chemical interactions with molecular targets within human body. Simulating these digital twins requires advanced computing techniques driven today by classical graphics processing unit hardware, and in future, by hybrid GPU quantum chipsets to solve quantum mechanical equations that govern electron-level molecular interactions. Recent GPU performance acceleration enabled these simulations to run at relevant scales, unlocking simulation's potential in previously unavailable ways. But quantum computers take this exponentially further. They can model electron interactions at level of fidelity classical computers can't achieve because quantum systems naturally represent quantum chemistry. The math describing how electrons behave in molecules is quantum mechanics. Using quantum computer to simulate quantum system is inherently more efficient than using classical computer to approximate quantum behavior. Approximately 7,000 diseases today with no effective treatment. Disparities in global health as treatments for many infectious diseases don't attract sufficient research funding and pharmaceutical attention. Jack Hydery, Chief Executive Officer at Sandbox AQ, states roughly 88% of drugs reaching clinical trials fail to make it through and gain approval. Quantum and AI technologies promise to redefine how to design therapeutics while providing often lacking datasets needed. Approaches using AI and quantum physics for scientific experimentation through computers unveil answers to questions previously answerable only through lengthy, costly physical experimentation. Insights gleaned from observing chemical interactions at molecular level generate data researchers need to develop promising new treatments for most challenging to treat illnesses. These aren't distant collaborations. These are partnerships formed 2024 and 2025, preparing infrastructure for quantum drug discovery deployment at scale. Molecules that took 10 years to validate now validated in months. Clinical trial optimization using quantum algorithms to identify patient populations most likely to respond. Molecular interaction predictions accurate enough to skip expensive failed trials. The drug discovery revolution transforming from decade-long gamble into months-long calculated process. Precise determination of Gibbs, free energy profiles for prodrug activation involving covalent bond cleavage, accurate simulation of covalent bond interactions. Both case studies featured covalent bonding issues encountered in actual drug design, benchmarking quantum computing against veritable scenarios, transitioning from theoretical models to tangible applications. Results demonstrate potential quantum computing pipeline for integration into real-world drug design workflows. Quantum computing across drug development cycle accelerates workflows and decision-making. Quantum approaches for molecular simulation predict drug target interactions and optimize clinical trials. Leveraging quantum capabilities could accelerate timelines and costs, bringing therapies to market. Goldman Sachs and QC Ware explored variational quantum circuits for volatility prediction and structured product pricing. Machine learning models trained on quantum simulation information predict molecular interactions and locate drug options with unprecedented speed and accuracy. Then classical systems. Quantinuum successfully implemented algorithm on Orion neutral atom quantum computer marking. First-time quantum algorithm used for molecular biology task of this importance. Understanding how ligands bind to proteins, cornerstone of drug development. Quantum-powered tools model these interactions with accuracy, providing insights into drug-protein binding mechanism under real-world biological conditions. By improving simulation accuracy and efficiency, quantum computing enables faster data generation feeding into machine learning models for drug discovery. Molecules that took 10 years to validate now validated in months. Module lattice-based key encapsulation mechanism based on Kristall's Kyber. Module lattice-based digital signature algorithm based on Kristall's dilithium. Stateless hash-based digital signature algorithm based on a Sphinx Plus. After worldwide call and competition lasting since 2016, evaluating dozens of candidates, these algorithms designed to be secure against both classical and quantum attacks with acceptable performance. The transition isn't optional, it's survival. Quantum cryptanalysis could literally break the internet. BCG reports published November 12, 2025 emphasizes companies should prioritize critical applications and systems starting as soon as possible to mitigate immediate threats and avoid escalating costs. Integrate crypto agility. Organizations need modular, automated, standardized cryptographic architectures, enabling rapid, seamless updates as quantum-resistant standards evolve. December 9, 2024, Google announces Willow chip with breakthrough claims. Hartmut Neven, founder and lead at Google Quantum AI. Global Risk Institute's Quantum Threat Timeline report estimated by 2034 between 17 and 34% chance cryptographically relevant quantum computer would exist capable of breaking RSA 2048 in 24 hours. U.S. Office of Management and Budget estimates transitioning prioritized sensitive information within U.S. government to post-quantum encryption costs approximately $7.1 billion between 2025 and 2035. Department of Homeland Security describes shorter transition ending by 2030. Commercial National Security Algorithm Suite 2.0 required for national security systems has PQC as preferred. As soon as 2025 and mandatory by 2030 to 2033 depending on application. Quantum computers arrive. Financial Services Information Sharing and Analysis Center released white paper late 2024 on building cryptographic agility in financial sector. Japan's Cyber Research Consortium working to develop and standardize PQC technologies. EU's Digital Operational Resilience Act and updated Network and Information Security Directive introduced stringent guidelines around encryption and secure key management for critical sectors. Your bank account, your medical records, your private messages, all sitting in encrypted form waiting for someone with quantum computer to crack them open unless migration happens now. The race isn't theoretical. The countdown started. 1.12 billion in 2024 to 1.5 billion in 2025. 33.8% compound annual growth rate. Quantum computing and financial services market valued at 0.3 billion, expected to reach 6.3 billion by 2023, representing 46.5% growth rate. Major financial institutions already investing in leveraging technologies. Goldman Sachs and QC Ware explored variational quantum circuits for volatility prediction and structured product pricing. These circuits offer a more expressive, compact way to model complex market dynamics than traditional deep learning architectures. Quantum principal component analysis reduces dimensionality of large data sets, critical for portfolio optimization and risk management. Classical Monte Carlo simulations, inefficient for real-time decision-making in volatile, fast-moving markets. Quantum machine learning provides tools to make process faster, more accurate, more efficient. Traditional methods. Paper overcomes limitations, hidden quantum Markov model in handling continuous data, proposing innovative method, converting continuous data into discrete time sequence data. Hybrid quantum computing model developed to forecast stock market trends. Model used to predict 15 stock indices from Shanghai and Shenzhen stock exchanges between June 2018 and June 2021. Experimental results demonstrate proposed quantum model outperforms classical algorithmic models, handling higher complexity, achieving improved efficiency, reduced computation time, superior predictive performance. JP Morgan and HSBC lead global banks in quantum technology race. BS papers. No one 49 published 2024 estimates high-performance computing market expected to grow to around $90 billion in 10 years. Assuming 10% reduction in costs from quantum computing would imply saving of $0.9 billion per year. Analysts estimate banking, financial services, and insurance sector has third highest potential. Benefit from quantum computing. Markets are chaotic systems. Chaos theory, together with quantum algorithms, proves markets are predictable to a certain extent. Quantum chaos traces patterns in seemingly random price movements. Financial institutions using quantum to spot opportunities, classical algorithms miss. We're halfway through 7 explosive predictions, and the next 3 get even more transformative. Comment your location so we know where quantum future is being heard. This research comes from Nature Biotechnology, January 22, 2025, on KRAS inhibitors, NIST's August 2024, finalized post-quantum cryptography standards, FIPS 203 through 205, and MDPI's August 2025 publication on hidden quantum Markov models predicting stock markets with experimental validation on 15 indices. Back to the chaos. Graphene, quantum dots with irregular boundaries and strong applied magnetic fields. Spatially random interactions believed responsible for formation of exotic phase of matter dubbed strange metal existing in high-temperature superconductors and twisted bilayer graphene at magic angle. These material platforms may play a role in future experimental implementations of quantum batteries. October 29, 2024, research published by Quantum Insider team from Robert Bosch, IBM Quantum, Argonne National Laboratory, evaluates quantum supercomputing in materials science. Ab initio calculations experience exponential growth in computational requirements as system size expands. Quantum computing could alleviate these challenges as quantum systems bypass exponential memory constraints, hampering classical methods. Quantum-centric supercomputing integrates quantum and classical systems for maximum real-world impact distributing computational tasks between quantum and classical processors. Specialized calculations integrate into existing workflows, helping filter noisy outputs from quantum devices, necessary for designing efficient, long-lasting batteries. These simulations expedite discovery of materials enhancing energy storage, essential for advancing renewable energy technologies. Thermal property simulation, another use case. Quantum computing enables detailed modeling materials responses to temperature changes relevant for aerospace engineering and climate science. U.S. Department of Energy, RPAE, announces $30 million to use quantum computing for groundbreaking chemistry and materials science simulations. Quantum Computing for Computational Chemistry program aims to develop quantum algorithms revolutionizing diverse areas of energy research, designing new sustainable industrial catalysts, discovering new superconductors for more efficient electricity transmission, developing improved battery chemistries. Penn State research published February 8, 2024 in Science describes combining 2 magnetic materials in critical step toward realizing emergent interfacial superconductivity. Superconductors widely used in digital circuits, powerful magnets in MRI and particle accelerators, and other technology where maximizing flow of electricity crucial. Researchers combined ferromagnet and topological insulator, producing robust superconductivity. Normally, superconductivity and ferromagnetism compete, but superconductivity in this system actually very robust against ferromagnetism. You would need very strong magnetic field to remove superconductivity. Understanding superconductivity would have enormous impact. Greater insight could pave way to real-world advances like phone batteries lasting for months, lossless power grids drastically reducing bills, or MRI machines widely available and cheap to use. Development of room temperature superconductors would transform global economy. They successfully implemented algorithm on Orion, neutral atom, quantum computer marking. First time quantum algorithm used for molecular biology tasks of this importance. Materials that were impossible to create or even model now being designed atom by atom, using quantum chaos simulations. Battery lasting months, not hours. Superconductors operating at room temperature. The materials science revolution isn't coming. It's synthesizing compounds in labs today. December 11, 2024, Google researchers publish theoretical study showing quantum computers could learn certain neural networks exponentially faster than classical algorithms. Nature Communications published January 14, 2025, details quantum advantage for learning shallow neural networks with natural data distributions. Quantum Statistical Query Framework, primary tool to study quantum algorithms for learning classical functions and search for quantum advantage in machine learning tasks. Researchers designed efficient quantum algorithm for learning periodic neurons over a variety of non-uniform distributions, first explicit treatment of real-valued functions. Proved problem hard, not only for classical gradient-based algorithms, workhorses of machine learning, but also for general class of statistical query algorithms establishing exponential quantum advantage. Datasets while emulating human perception and judgment. Findings suggest quantum tunneling neural network model provides compelling evidence of potential to replicate human-like decision-making. Contemporary machine learning systems excel in recognizing classifying images with remarkable accuracy. But like many computer software systems, they can fail generating confusing, erroneous outputs or deferring to human operators to interpret results and make final decisions. Candidate for AI's data-driven learning capabilities. Many of quantum computing's biggest scaling challenges may ultimately rest on developments in AI. State-of-the-art AI techniques already advancing challenges across hardware and software stack needed to develop useful quantum computing from device design to applications. Approach to time series forecasting. Chaotic systems exhibit rich, complex, nonlinear dynamic behavior characterized by sensitivity to initial conditions, inherent randomness, and determinism. These features closely mirror properties of time series data-making chaos theory, promising complement to deep learning for enhancing forecasting methods. Chaotic systems generate chaotic sequences with desirable randomness and distribution properties. Using these sequences as initial parameters in various layers of deep neural networks increases randomness and complexity of models, improving ability to model and forecast time series data accurately. Experimental validation conducted on 13 available time series datasets assessing models' forecasting accuracy, runtime, and resource occupancy. Integration of Chen chaotic system with deep learning frameworks including long short-term memory. Neural basis. Expansion analysis and transformer architectures demonstrates impact of chaotic systems on various deep learning models. Machine learning that was hitting walls in pattern recognition, now breaking through using quantum-inspired chaos mathematics. Neural networks that couldn't handle certain periodic functions, now solving them exponentially faster with quantum statistical query frameworks. The AI you interact with tomorrow being trained using quantum chaos principles discovered this year. July 18, 2024, Quantum publishes research on exploring quantum chaos in nonlinear systems. 2024 study in scientific reports delves into dynamics of hybrid systems, demonstrating how chaotic parameters and coherence fractions influence pattern formation under influence of condensation. Research provides framework for understanding how chaotic and coherent behaviors coexist and interact in hybrid quantum systems, opening new avenues for experimental applications in nonlinear phenomena. Experimental studies of quantum chaos in nonlinear systems involve techniques such as interferometry and spectroscopy. These methods allow researchers to probe dynamical properties of quantum systems and identify chaotic behavior. Interferometric techniques provide means to investigate phase transitions and coherence properties of particles within nonlinear systems operating at low temperatures and momenta. Quantum systems switch from orderly motion, like clock, to random erratic motion, like asteroids moving around an early solar system. Using computational analysis of photosynthesis, model collaborators at University of Illinois, Urbana-Champaign showed theory can predict nature of motions in chlorophyll molecule when it absorbs light. Logan Willine's theory opens wide array of scientific inquiry ranging from theoretical exploration of fundamentals of quantum mechanics to practical applications. The introduction of noise can help reduce dimensionality of dynamical system. Suitable variable transformation of deterministic three-dimensional Lorentz system yields two-dimensional stochastic system. This offers potential route to gauge impact of noise in quantum computer using near-term quantum hardware. By integrating modified Lorentz system of reduced dimensionality on quantum solver, imperfections of hardware might allow exploration of chaotic behavior of effectively stochastic system and reproduction of Lorentz attractor. Quantum chaos theory, with ability to model phase transitions in complex systems with multiple interacting variables, provides tools to identify warning signals before tipping points hit. Early warning systems, detecting when climate subsystems approaching critical transitions. Models running scenarios accounting for quantum-level chaos in atmospheric chemistry and ocean thermodynamics. Predictions. Classical supercomputers can't make because the mathematics of phase transitions in chaotic systems requires quantum approaches. Computers. Mathematician Terence Tao pointed out if they could, perhaps fluid could be programmed to slosh in just right way to bring forth tsunami of unlimited violence. Such tsunami would be unphysical, since no wave can accommodate infinite energy in real world. Anyone who found such algorithm would prove theory of fluids called Navier-Stokes equations, predicts impossibilities, another million-dollar problem. Miranda with Robert Cardona, Daniel Peralta Salas, and Francisco Presas showed fluids can flow in complicated ways that trajectories through them become undecidable. Climate scientists and meteorologists run computer simulations, treating ocean as if it were continuous fluid because no one can analyze ocean molecule by molecule. They need infinite to help make sense of finite. Physicists must accept new obstacle in quest to acquire foresight. They could conceivably work out all laws that describe universe just as they have worked out all laws that describe pinball machines, quantum materials, and trajectories of rubber ducks, but they may never be able to predict everything these laws entail. Using that boundary to make best possible predictions within realm of knowable, climate models that honestly communicate uncertainty ranges accounting for chaotic tipping point probabilities. Early warning systems that say we're approaching region where our models lose predictive power, evacuate now. The humility to know chaos exists even in quantum realm, but the power to predict further into that chaos than ever before possible. December 13, 2025, accessed research on azoquantum, Sing N. Kit's article, Retrieving Latest Developments in Quantum Chaos Applications. The field exploded 2024 through 2025, with practical implementations across 7 domains transforming from theoretical physics into applied science changing lives. Nature Journal. November 2, 2024, publishes Breakthrough Confirming Eric Heller's Z. 1984 theory. Quantum scars are real. Electrons in confined quantum space follow predictable paths through apparent chaos. Team at UC Santa Cruz proves it experimentally. The implication for information processing already being explored, nudging electron orbits to carry information predictably across devices. It's key that unlocks all 7 applications. Weather chaos becomes predictable because quantum chaos mathematics reveals hidden order in atmospheric turbulence. Drug molecules that seemed impossibly complex to model now tractable because quantum chaos finds patterns in molecular interactions. Financial markets exhibiting quantum-like behavior in price movements because underlying chaos follows quantum mechanical principles, even in classical systems. Materials that shouldn't exist becoming designable because quantum chaos maps impossible phase spaces. AI learning exponentially faster because quantum chaos provides training frameworks classical systems can't replicate. Climate tipping points becoming detectable because quantum chaos identifies signatures of impending phase transitions. Cybersecurity revolution happening because quantum chaos both threatens current encryption and provides mathematical foundation for unbreakable quantum-resistant algorithms. Domain. When D-Wave's quantum annealer solved weather simulation in under 30 seconds, that classical supercomputers need hours to compute, they demonstrated quantum hardware reached threshold where chaos becomes advantage, not obstacle. It was recognition quantum computers capable of breaking current encryption arriving within decade. U.S. government budgeting $7.1 billion for transition between 2025 and 2035, because harvest now decrypt later attacks already happening. Financial institutions, Goldman Sachs, HSBC, JP Morgan Racing, to implement quantum algorithms for trading aren't speculating on future technology. They're deploying quantum chaos mathematics today for competitive advantage, measured in microseconds and millions of dollars. Interactions. Classical methods can't model. The materials science revolution RPA-E funding with $30 million isn't about distant future energy storage. It's about designing room temperature superconductors and batteries lasting months using quantum chaos to map phase spaces where those materials can exist. Domains simultaneously. Weather forecasting, gaining 3-day advance warning windows. Drug discovery compressing decade timelines into months. Cybersecurity racing to rebuild encryption infrastructure before quantum apocalypse. Financial markets using quantum algorithms to game chaos theory. Materials, science engineering impossible substances. Artificial intelligence, learning from quantum chaos principles. Climate science detecting tipping points before points of no return. The predictions aren't theoretical. They're experimental results published in peer-reviewed journals with performance metrics proving quantum advantage. And now 7 ways that quantum order in chaos predicts futures classical computers can't see. Weather disasters avoided, drugs discovered, encryption rebuilt, markets timed, materials engineered, AI enhanced, climate tipping points detected, all because chaos at quantum level isn't random, it's predictable, and we just learned how to read it. Measured in 91 qubits running 4,000 operations, simulating many-body interactions, calculated in under 30 seconds for 10-day weather forecasts, synthesized in 15 KRAS inhibiting molecules with 2 showing cancer treatment promise, encrypted in post-quantum algorithms, securing 40 billion connected devices, traded in quantum-enabled algorithmic systems, processing microsecond advantages, designed in room temperature superconductor simulations and battery chemistries, storing months of power, trained in neural networks learning exponentially faster using quantum statistical query frameworks, detected in climate models, identifying phase transition warning signals.